Delhi Technological University is home to over 15,000 students, and right now, a large portion of that population is pushing hard into the deepest ends of artificial intelligence and machine learning. Take a field called Vision and Language Navigation, or VLN. The goal is to teach an AI to see its physical environment and follow complex human instructions at the same time. To make that work, you need embodied AI agents. These systems require massive computational power to simultaneously process sights and words in real time. But here is the problem. Despite the high-level math and the innovative ideas, DTU researchers are completely blocked. They have almost no local GPU computing power. Brilliant ideas are being mapped out on whiteboards, and then they stay there. The university simply cannot physically process the data the students are generating. To address this, the DCE Alumni Batch of 2001 stepped in. They pulled together a seed fund of 5.4 million rupees to tackle the compute crisis directly. But in the world of high-performance AI, 5.4 million rupees is a drop in the ocean. When you compare it to standard corporate AI budgets, which easily clear $100 million, the economics are brutal. In today's market, that alumni fund buys exactly one high-end modular server featuring a single NVIDIA H200 GPU. You cannot support an entire university of engineering students on one single graphics card. The math does not work. Buying out of this bottleneck is impossible. It requires a structural engineering solution instead of just throwing money at hardware. DTU faculty and US-based alumni designed a workaround. They launched a 3-month pilot program bypassing hardware limits using a human network. Step 1. DTU teams act as product managers, writing code locally in India. Then, this code is shipped to alumni in the US, who leverage American computing clusters to run the heavy workloads. Finally, processed data returns to India for analysis and co-authoring papers. This specific workflow is already allowing DTU students to target the most competitive global AI conferences, like AAAI and NeurIPS. Through human collaboration and network bridging, DTU researchers now use international supercomputing for a fraction of the hardware's market cost. This brings us back to that 5.4 million rupee fund and its actual strategic purpose, building the local foundation. This illustrates multi-instance GPU, or MIG technology. It allows the university to maximize that single server by slicing it into several distinct processors. MIG lets multiple undergrads log in simultaneously for basic AI literacy and data cleaning. The server handles local preprocessing, while heavy training tasks are shipped overseas to the alumni network. The local server acts strictly as an on-ramp, preparing the data before it accelerates onto the global supercomputing highway. This is the ultimate target state that the pilot project proves, the hybrid capacity model. The core is the Alumni Consortium Gateway, a secure data bridge where massive models are shipped to tap into world-class research capabilities. DTU no longer needs the budget to host massive data centers. They simply need persistent access to this distributed global network. To support the entire university, the network has to expand beyond a single pilot. This is a direct call to DTU alumni, specifically US university professors and tech engineers, to open their computing clusters to the consortium. By donating access rather than just money, alumni ensure that the next major AI breakthrough carries a DTU student's name.